In this video, I want to have a look at differentiation problems that involve negative powers. So our basic rule for differentiating x to the power of n applies for any function where n is a rational number. So just to jog your memory, our rule for differentiating that is if we have a function x to the power of n, then the derivative, we multiply by the power, so we'd have n, x, and then we reduce that power by 1, so n minus 1. So that will apply even if that power is negative or a fraction. As long as it's a rational number, that still works. In some cases, when we have negative powers, we're going to rewrite our function into index form so that it has a negative power before we can differentiate. So it just makes it a bit easier. Okay, so we've got 5 examples here to start us off. Our first one is f of x equals 2x to the power of minus 4. So this one already has our power up there in the negative. So we're going to have f dash x equals, so we're going to go 2 times minus 4 will give us minus 8 x, and then reducing that by 1 would bring it down to minus 5. So we're going to have minus 8x to the power of minus 5. For our second example, at the moment our power is positive, but it's also in the denominator. So what we want to do before we differentiate that is just rewrite, before we differentiate, we're going to rewrite that with a negative power. So 1 over x would be the same as x to the power of minus 1. And once we have that, then we can differentiate. So f dash x would be minus 1, x to the power of minus 2. Now usually we'll write our answer back in the same form we originally had it. So we had positive powers there. So let's rewrite that as minus 1 over x squared. So just writing our answer back in the same way the question was given to us. All right, question 3, we've got y equals 3 over x squared. So again, we're going to rewrite that. So we have 3x to the minus 2. Now that we've rewritten it, we can differentiate. So we had a y here, not an f of x. So instead of writing f dash x, we're just going to write y dash. Or we could write dy dx. So if we differentiate that, 3 times minus 2 would give us minus 6. And we have x to the power of minus 3. Again, just rewriting that into the same form that we had it with positive powers. So we'd have minus 6 over x cubed. All right, our second last one, number 4, rewriting this one. Now that 5 isn't affected by the power, so it's going to stay in the denominator, but our x to the power of 7 is going to come into the numerator and give us a negative power. So we're going to have x to the power of minus 7 over 5. So that's just rewriting it. Now we need to differentiate. So we're going to have f dash x would give us minus 7 x to the power of minus 8 over 5. And then if we rewrite that, bring that back down so it's a positive power, we'd have minus 7 over 5x to the power of 8. All right, our last example, one more. We're going to do each of these separately. So we'll rewrite it all to bring those powers up the top first. So we'd have 8x to the minus 5. And then for this second one, that 3 is going to stay in the denominator. So we'd have minus x to the minus 2 over 3. Now I'm just going to actually write this up here because I've run out of room down there. So for there, because it's a y, again, we'd have y dash, or for this time, let's write dy dx. It all means the same thing, that notation. It's just finding the derivative. So if we do that for this first term, we'd have 8 times minus 5 would give us minus 40, x to the power of minus 6. And then for this second one, we've actually got a minus 1 times minus 2, so we'd have plus 2, x to the minus 3 over 3. And just rewriting that again, so we've got positive powers, so we'd have minus 40 over x to the 6 plus 2 over 3x cubed. And I just want to have a look at one more thing. So our last 2 examples look a little bit different. In these ones, we've got multiple terms in the numerator all over that same denominator. So what we're going to do is we're actually going to break this up into its separate fractions. So we can write this first one as 5 over x plus x squared over x minus 6x cubed over x. So that's just broken it down into 3 separate fractions. Now we can go through and either simplify or rewrite those so that they have a negative power. So 5 over x, we could write that as 5x to the minus 1. X squared over x would just leave us with x once we cancel out 1 on the top and 1 on the bottom. And this last one would give us a minus 6x squared. So now we can differentiate. So f dash x. So that would give us minus 5x to the minus 2 plus 1 minus 12x. So these two terms here are fine, but this one with the negative power, because there weren't any negative powers in our question, we're just going to rewrite that one. So we'd have minus 5 over x squared plus 1 plus 12x. Alright, so that's our first one. Let's have a look at one more. We're going to start off doing the same thing. We're going to rewrite this into its two separate fractions. So we'd have 6x to the power of 4 over x squared plus 3x to the power of 5 over x squared. Now both of those are going to simplify down. So we could just have 6x squared plus 3x to the 3. So there's actually not any negative powers in this one this time because the powers in the top are all larger than the power in the bottom. But we can differentiate, so y dash would give us 12x plus 9x squared. Alright, so those are a few examples of differentiation with negative powers.